systems of linear equations. So this problem wants us to solve the following system of equations, where we have 2x plus 3y equals to 6, and 4x minus y equals to 5. So we are going to use elimination to solve this problem. So we are going to try to eliminate one of the variables. So in this case, I'm going to try to eliminate y. So in order for me to eliminate y, I would need to have a 3 here, such that when I add the two equations together, the y get canceled. So therefore, I can't just put a 3 here legally. The only option I have legally is that I can multiply the entire equation by 3. And that way I will get the 3 next to the y. So if I multiply the entire equation by 3, then I get 3 times 4, 12x. And then now when I multiply 3 times negative y, I get negative 3y. I also have to multiply 3 times the 5, that gives me 15. So what I did, I rewrite the equation by a multiple of 3. And so now I can take the first equation and write it below, which is 2x plus 3y is 6. And the elimination method said now add the two equations together. So 12x plus 2x is 14x. Here, when you add the y terms together, the y get canceled. So you have now 21. So we're solving for x, so we divide both sides by 14. Divide both sides by 14. And so x is equal to 21 over 14. Of course, you have to reduce your answer. So if you reduce 21 over 14 by dividing top and bottom by 7, then you end up with 3 over 2. So that's just the x value. Now we need to find the y. So since the x value is a fraction, you can substitute the fraction inside one of the equations and then solve for y. Or what I recommend, you go back and eliminate x instead. So now you need to find y, so eliminate x. So you have two choices here. You can substitute, for example, you can substitute the x value into the first equation. So it looks like this. And then, reduce. So you end up with just 3 plus 3y equals to 6. And then you subtract 3, you get 3y equals to 3. And then your divide. So you divide, so you get y equals to 1. Right? So you can do it that way. Or what you can do is go back and eliminate the x instead. Right? So normally when we get a fraction, I always recommend that you go and eliminate the other variable, but this one works out fine. If you replace x with 3 over 2, then the 2 cancel, you get 3, subtract 3. And then you divide by 3, you get 1. But you could also have gone, so let's take the two equations. 2x plus 3y equals to 6. And 4x minus y equals to 5. So we want to solve for y in this case, so we want to eliminate the x. So you need to think of what can you multiply the 2 by, right? To eliminate. So we need a 4, right? So if because we need to have the same number. Over here we have 3 for the y, 1 positive, 1 negative. So if we multiply the top by -2, then that's going to give us a -4 in front of the x. And so when we add -4 with +4, then the x is going to get canceled, right? So let's rewrite this new equation. We get -4x minus 6y is equal to -12. So now what we can do is add these together and the x get eliminated. It gives you 7y equal, when you add the 5 and the 12 together, you get -7. So you divide by -7, divide by -7, and then you get y equals to 1. Right? So that's 2 ways. Doesn't matter which way you go. I just recommend that if you solve the first variable and you get a fraction, since most people don't like to deal with fraction, then just go back and eliminate the other variable. So first we eliminate y, so you go and eliminate x. If you solve for y, you get a fraction, then you go back and eliminate y, right? So you can do it that way, or you can just do the substitution like we did here. So either or, you get y is 1, x is 3/2. Some professor wants you to write it as a point, so the point would be 3/2 for x and 1 for y. And so either or, the solution is the point of intersection. So you could write this, or you can leave them separately. X is 3/2 and y is 1.